Hello, my name is George Samuel Mahrous Khalid. I'm a student, master degree in Deep Learning Care University. Also, I'm graduated from Udacity for Machine Learning Nano degree. Today, I will explain how to build menace-digit classification with TensorFlow in a deep learning. This is a dataset from 0 to 9 handwriter images, gray images by 28 by 28 pixels. It's a gray images. First, I will import some libraries help me to build this model, like NumPy, scikit-learn, to give me a matrix for accuracy, and also I used matplotlib, and the main library for me, the TensorFlow, and some libraries for it is a Keras. Okay. First, I will download the training set from the internet by this code. To split the dataset for training and validation and testing set, and call the pre-processed menace to load the data set. This data set is 60,000 images divided by 50,000 for training and 1,000 for the validation. First, I will show some example for this image, like 0. In this images will we be show and say that is a white image. The value of the white image is a 0, and the black color is a 1. And this is a representation of this column for that, and another value is ascending like that, and also this is a sample of the dataset. Okay, I try also to show the color images by that code. Okay, first, for any deep learning classification, I will build this model by flattening any input like that by 28 by 28 equal 784 with a training example reshape. This is the input for the model. Also, I use the matrix placeholder for flattening xtrain, and to convert ytrain to one hot encoded vector. One hot encoded vector like that. When I represent 5, it's that 0, 1, 2, 3, 4, and in a 5 we write 1. For the 0, it's the first one. 4, 0, 1, 2, 3, 4. If I need 6, 0, 1, 2, 3, 4, 5, 6, and right here 1. It is good to show me how to split the data for the training set and validation set. Okay, I make parameter for the weight and pies for TensorFlow.variable.random number, and this is the shape for the weight. The flatten input for 28 by 28, and the 10 is the number of the classification, and I choose a standard deviation for 0.01, and I name it the W of the weight. Also bias, I named it B. TensorFlow.variable, TensorFlow.0, not important for the bias to be any random normal, because it's not important for I initial the bias by 0, and the shape of the bias 1 by 10, because I use the linear model for these steps. Second, I will be define a placeholder for the input data. For input X, for TensorFlow placeholder, and this is a shape, and TensorFlow for floating 32, also for input Y. Okay, for the linear model, we can define WP, and the linear model equation for W transpose X by plus B. I name it Z in this example for the logits, and I use this function matmul for the input X, multiply for W, and added the bias for it. This is the linear equation. Okay, in this equation we can make that the output, and need it for the output to be probability. How probability to be 9, to be 5, to be 1 of that, and of the high probability we can the model choose the high prediction or high accuracy rate. High prediction allocated to 9, for example. Okay, assign bias and weight to be null tensor. Now we are going to create the weight and bias. For the purpose they will be used the array filled with 0. Again, bias, it will be initial to 0, not important, not affected for our model. The value that we choose here can be critical, but we will cover better way on the second part instead of this type initialization. Okay, here I use softmax to make probability for the output, and use argmax for the output. Okay, also to have a good minimization for the error, I use loss cost function to reduce the mean by using softmax cross entropy used for any classification. Also, I used Adam optimizer for a back propagation to give a good update for the W and B. Okay, also I will be used 40 epochs and make batch size for this number, and batch size for a good algorithm for to split the blocks of the training set to be focused for new weights for that, like that. I will show that. If I use batch size, the weight like that. If that is minimize, batch normalize is it's be faster to get a global minimum for the error. When I use this linear equation for that, I will get a 93 accuracy for a linear model. I will be used multi-layer perceptron for using two hidden layer to have more accuracy, like 97 validation accuracy. I identify hidden layer 1 to make that. This is a input layer. I make first hidden layer, and that's the weight. First hidden layer. Also make hidden layer 2. Also the output layer from 0 to 9, and make softmax to give one of that high probability, like when the input like 3, softmax will be giving me the model prediction as a number 3 for 70%. Okay, I used also loss function to reduce the error, and use the Adam optimizer. Is very good Adam optimizer, and run the session. And finally I make for loop to loop for the batch size for each epochs for 0 to 40. Finally I use high accuracy for training set for 98%, and validation error and validation for the testing or 97%. This is a very high accuracy by using multi-layer deep learning. In the future will be use the convolution neural network to apply for the MINIST dataset. Okay, thank you, and I will be see you in the rest. Okay, bye bye. Thank you.